Hi, welcome back. Let's take a look at the compression algorithm now working. There's no tokenization, but actually works pretty well. Let me show you. So what I'm doing here is similar to how I approached it initially. There were a number of issues with that. I'm actually using an intermediate format to do the compression. What I mean by that is as I do a find and replace of the larger string is getting smaller and smaller and smaller, it then changes that to an intermediate token. There's an apostrophe here which I don't use anywhere in the code, so that it does a textual translation first, and then afterwards it will then convert that to a binary stream. It's easy to do it in 2 steps. If I then run that, so it's got 3 maps per file and it compresses each of them, so this is going to take a little while. 33 files, 34 files, something like that. Almost there. Okay, so we have a maximum file size of 1.6K, which is okay. Let's now take a look at these files here. They've obviously been compressed. This is what they look like. So we have the marker value at the start saying this is the start of a map, 15 characters for the level name, and then all the other compressed stuff. If I then look at this, where is the thing? File Explorer. So I've got another program that I've made. Replace those. To actually do the testing. It's easier to have a separate project to do the testing. So all this does is load and decode the map. It doesn't do the full map processing. It's responsible for essentially loading the map from disk and then just displaying it on screen. So it doesn't do any of the post-processing of non-player characters, switches, all that kind of stuff. It doesn't do any of that. Its only job is to do the map decompression. So it finds out the offset of the map within a file, as it did before, and then it has this little. If I just collapse this, you'll see roughly what's going on. So when it starts, it will it reads everything into a buffer. Okay, so the buffer itself is defined up here, currently 1200. That's actually wrong, but we'll come back to that. And so that's now in a file buffer. So that's pretty quick. That program. So it's not doing any processing on the file at all. It's just putting it into a buffer, which is now achievable given that the file sizes are significantly less. 1.6K is the max. Brilliant. So we can have maybe a 1.7K buffer in there, and there's enough memory on those machines just to handle that. So then it goes to the process of processing the map. So if it's not found the map, then it will go through the file buffer, which is essentially just a byte array, and it will keep going. Once it's found the map, but it's not loaded the level name, then it will say, "Oh, I found the map. I found the map, and I'm going to start loading the map name." And each one of these will affords a position on. This is not a for loop, this is a while, so it will just keep going. Once it's done the map name, it will then start processing the map itself. So if everything is below 127, then it just bungs it in the array. If it's above it, then you have another little loop which then populates the map array given the number of characters from this formula here. So it's the byte value minus 127. So the first character, as we said in previous videos, is the number of repetitions. The second character is the character to repeat. So that's it, really. One of the interesting things here is we've got this thing, which is the file offset. So this is the chunk within the file where the map is, and then it uses this bit here to every time it finds a file marker, it says, I found a marker. In this case, if it goes to like the second map, for example, it's found the marker, that's gone up twice, that then equals the offset, and now the marker is the correct offset, so it starts loading the file. Right, okay, that's enough of that. Anyway, we go to the top here. This is the start of it. So it's loading map 1 here. So you just give it the level number that comes in. and then it calculates the file. So there's only 3 files in the demo, but it kind of works. So we've got 1 here, 4, and then 9. So we should be going to the first file. So that'd be the first map in C1. Number 4 would be the first map in C2. Number 9 would be the last map in C3. So let's go and run that. And because it's a small project, it loads very, very quickly, which is great. Right, now. Okay, so it's loading the first map into memory. That's already loaded. It's found the entrance, load complete. So that's much, much, much quicker. If I then do that, it displays the map. That's perfect. If I then go to the next one, it's immediately loading that. So it's the offset 1 in file 2. Bosh, loaded. So the amount of time it takes to load the whole thing is much less. This last one is going to be the last map in C3 in the last file. So let's do that. So it loads into the buffer. Done. So the actual processing of those files once it's in the buffer is really quick. Now there is a slight problem here because this buffer here has the previous contents in there. The reason for that is this here. So that is actually set too small. So if I set that to the correct value and run this again, that should fix that. The thing is, the number of bytes for each map is now different. So each map will have its own amount of compression, if you will. So some maps will compress very well, other maps won't compress as well. So the largest file there, 1.6K, so that one works. Yeah, the largest file, 1.6K, that was mentioned in the compression algorithm. Let's get back to here. Let me just show you this first. So it's loaded the file, it's processed it, and there you go. That's now correctly displayed. So that's really cool. That works really nicely. Oh, is it clear on that? I'm not sure what it is. Oops, there's not much to see. There's just a syscall. Anyway, whatever. So that's working. That works really nicely, and I think you'll agree it's a lot quicker than previously. It's possible we might even be able to have larger files, but I think so if we're setting this to 1.7K, this other one here, or even less, that says 1649. If we set that to 1650, that could be enough. So that buffer is always set to 1650, and we're good to go. I think that works very well. The performance is a lot better than I thought. The nice thing here is the fact that it's consistent. So you don't have even if it was slightly slower, what you don't have is a variable delay between file sizes. So previously, if you had to wait with 5 maps in a file, and you happen to be on map 5, then you've got to wait a lot longer. It's actually quite annoying. I think this will be quite good. Obviously, this doesn't have any of the processing. So if we go back to the main code, and we just move that down a little bit and go to load map. So this thing here, we recognize all this stuff is the same code pretty much. A few noises coming up. This is how it's processing the file name, all that kind of stuff. Now this is where it gets more interesting. So in all this, what this is doing is processing the various switches, player position, NPCs, all that stuff, right? This is doing a lot of work. Now, I say a lot of work, it's doing work. But it's not that much, really. There's a bit of code, but it's not that complicated code. The interesting thing is when I port this routine to here, instead of going through a while loop and getting byte for byte from the map, it will be interrogating the file buffer. So that will be extremely quick. So instead of this, it's this, which is interesting because obviously the it's taking data from the file buffer and putting it into the map file. So I'm going to have to swap it a little bit, because in here it has a flag to say I am in the middle of processing the actual level. I got to the right place. You don't need to do that with here. So it's actually pre-populated the map. So what I will have to do is then, rather than do this, is then work through the map. So if we look at the map display routine, essentially it will go through all of the items in the map that's been dumped out by the extraction routine, decompression routine. Map processing, i.e. all this stuff, player position, switches, blah blah blah, will be replaced in here. Yeah, so that's different. That is the major difference. You'll be processing the actual map. So imagine you grab hold of the file. First off, you calculate the offset, the file name and the offset. Then you grab the file, and then when you get to that offset in that buffer, you then dump that data into the map array. So you've got the map already done for you, but the map is the unprocessed map at this point. Then next thing you do is you go through, once I've built it, is you go through this loop here and update the map afterwards, replacing the various things that you need to replace. So for example, if you have a transporter, then the transporter will set the various things it needs to set, and in here is actually setting the map array. You don't need to do that. A lot of these things it won't need to set any of this because it's already been set. However, for things like this, if you have a switch, then the switch will need to modify the map. So there'll be certain areas where the map is changed. So when you go over a switch and it will change some place on the map to a wall, for example, there, then what it will do is if you see a 0 on the map coordinate itself, it then replaces that with a wall, great, and record the switch position. So that's cool. That works really nice. That should work really nicely once I've built it. Yeah, I think this is going to work nice. And as I mentioned before, I'm looking to trying harmonizing everything so it's the same on Apple as it is on Atari, on C64 and everything else. It should be the same code base. Right, we are getting there. It's a slow one, and this compression algorithm has proved to be a pain in the ass. This is the third rewrite of this program, and for some reason it was just really cool. Actually, that's not the right one at all. That one. This is the third rewrite of this. So the original code here for compressed map is complete nonsense. None of that would ever have worked properly. This does have tokens in there. Fine, I could do that, but you know what? At the moment, I'm not going to bother with any of that stuff. I need to get it working as a baseline, and if I can get tokens working later, great. I'm not too fast. But yeah, this has been a right royal pain in the ass. This working method is actually quite small. As a lot of these things, you do programming for long enough, you tend to find that you can very easily over-engineer stuff, and then a simple solution, are you thinking logically, in this case just using an intermediate find replace before you convert to the binary stream, actually worked out quite well. Anyway, so that's it for now. Yeah, so I guess the next lot is to start converting and porting this back in to the main code, and we'll see what I keep going to the wrong project, into the main code, and we'll see what happens. Yeah, it's going to be interesting because as the thing loads, I'll actually run this again, you'll see here that it's that initial load is quick. As soon as it's got the data, the entrance bit comes up straight away. So if I do that again, you'll see here it loads the file. It's actually less visible. So on this last one, it'll be more visible. So it will load the file into the buffer, and it goes through the array. And there's a slight delay before you can't really see it. There is actually a slight delay before the name of the level comes up. There's a slight delay. So anyway, it's cool enough. The intro screen, there is going to be some delays here, and I'm not even sure whether the previously we had a little ... progress bar. I'm not even sure whether it's worth showing now because it's probably going to be too quick. Famous last words. Let's see what it is for real on the C64. Certainly on the Apple, it will be blindingly quick. The file processing is much quicker and the base speed seems to be quicker. Anyway, let's see what we can see. See you next time. Cheers.